Hey, this is Mr. Aiden. This is AP Chemistry 2013 AP Exam Practice Problem number 5, and this starts our review for the AP Chemistry exam here in 2020. And hopefully you've been staying safe with the coronavirus. I've had some good news over spring break. Mr. Aiden got engaged, and so hopefully you can have a little party for Mr. Aiden by yourself, social distancing, and just individually in your own home. So we're going to be going through practice problems each day, and you're going to want to score yourself, and then you're going to want to go to MrAiden.com and put your daily AP Chem test score where it says put your daily AP Chem test score here each day. So you're going to give me some feedback of how you did each day. So if you haven't done this problem first, make sure you do it right now, and then you can take a look at this video and score yourself. So we're going to start with this problem number 5. We have a sample of a gas, C2H4, and it is at 300 degrees Kelvin. It goes up to 450 degrees Kelvin, and you can see how the pressure increases. And they say describe two reasons, okay? Two reasons, and we want to take a look at what happens during the molecular level. And so the first reason is as the temperature increases, what is happening is the speed of the gas, the average speed of the gas is increasing. So each particle is getting faster and faster and faster and faster. And so what does that do is those molecules collide more frequently. So the frequency of the collisions increases. That is one of your reasons why. The second reason is as the temperature increases, the average kinetic energy increases. Okay, so one is dealing with the speed increasing and the frequency of collisions increase, and then the other one is the average kinetic energy increases, which means the molecules are striking the walls of the container. They're colliding with the walls of the container at a greater force. So you can see one of them, as the speed increases, the frequency increases. The other one, as the kinetic energy increases, they hit with a greater and greater and greater force. And so that is actually worth 2 points. Okay, 1 point for each correct reasoning, so that's worth 2 points, so you can kind of score yourself. The B goes on to a chemical reaction. You can see the C2H4 plus HCl produces C2H5Cl. You can see the delta H is a negative, which means we know it is an exothermic reaction. And they say when this reaction happens, the total pressure increases. But then as the reaction proceeds, the total pressure decreases. So why would, again, we want to look at the molecular particle level, why does it decrease? Remember, pressure not only deals with, we're keeping the same temperature here, the volume of the container isn't changing, but the temperature is not changing. So what is changing is the number of moles. You can see as our reactants have C2H4 and HCl, that is 2 moles of my reactants. And what is that becoming as we get our products is that's becoming 1 mole. So as the number of moles decreases, the total pressure ends up decreasing as well. Okay? And so that is 1 point for B. 1 point for that correct reasoning for B. Then we go into C and D, and we're hitting a kinetics type problem. You can see we have 2 mechanisms here. We have step 1 and step 2. You can see we want to know the rate law for the reaction above. Remember, the rate determining step is the step that determines our rate. That is our slowest step of our reaction, which means for C, my rate law is rate equals K times C2H4 times HCl, and that is dealing with my reactants right there. That's worth 1 point. D is asking for the intermediates. So we're looking for our intermediates. Intermediates is something that's produced and then used right away, something that's produced and used right away. So you could have used the C2H5 plus or the Cl minus, either one, and you only get 1 point for either of those 2 species right there. Okay, so right now we are A was worth 2 points, B was worth 1 point. and C was worth 1 point, and D was worth 1 point. And so now we go on to the last part of the problem, is we're looking at a thermotype problem. We're looking at the potential energy. Remember that potential energy always starts with my reactants. So my reactants are right here. That's an awful line right there, so I'm going to make it a little straighter right there. There we go. And that is my C2H4 plus my HCl. And you can remember there was two mechanisms. There was two steps, and the first step took the most time. It was the slowest step. So that's going to have the highest activation energy. The second step is going to have a smaller activation energy. And if you remember, it was an exothermic reaction. So you remember right here that this difference right here between the products and reactants is my delta H, and there are my products right there. And so that is right there for E. You want to know how we grade it. The 1 point is for the products, the potential energy of the products is lower than the reactants. So 1 point gives you that delta H becoming negative or exothermic. The second point is that you have two humps in your, so the second point, that's worth another 1 point right here, is when we have two humps that shows a two-step process. So E was worth 2 points for drawing that graph. And last but not least, we're looking for F, and F is looking for the activation energy in step 1. That is the activation energy in step 1. That's the energy we have to overcome in order to get my reaction to occur, and that would be for F, and that's of course worth 1 point right there. So if I review, we have 2 points for A, that third point is for B, fourth point, fifth point for C and D, 6th point, 7th point for E, and 8th point for F. And so you're going to go to MrEaton.com. You're going to go to where it says put your daily AP Chem test score here each day. Put in your AP Chem test score of how many you got out of 8. And have a good day, and I'll see you tomorrow.